This is part 5 in a series of videos on graphing exponential functions. And what we're going to focus on here is graphing exponential functions in the form y is equal to a times b raised to the x minus h plus k. And an example of that would be y is equal to 2 times 3 to the x plus 4 plus 5. Now let's go through and make sure we identify the parts correctly here. In this particular case, a would be 2, and b would be 3, and h here would be a negative 4, whereas k would be a positive 5. Now the trick here is that h always changes signs and k doesn't change signs. And this works just like how you graph exponential functions, where the h here moves it left and right, and the k moves it up and down. So the h moves it left and right, and the k moves it up and down. And the h changes signs, but the k does not. That's the first key thing to remember. Let's do another example where we identify the different parts of the graph. So let's, as an example, look at y is equal to 2 times 0.75 x minus 4 plus 1. So here a is 2 and b is 0.75. Now the first thing we notice is that since b is a number between 0 and 1, this is an exponential decay problem. And we want to contrast that with the previous example where b was greater than 1. Since b was greater than 1, this would be an exponential growth. So those rules are exactly like they were before. Now let's look at h and k here. Here's h, and there's k. The h changes sign, so that's a positive 4, so that moves it left and right. Since it is a negative 4 and we change the sign, that moves it positive 4. Another way to say that is that moves it right 4. And the k moves it up and down, and it doesn't change signs. So since that's a positive number, it doesn't change size, that means it moves it up 1. And that's how you determine whether it's h and k. The next thing you need to remember is you need to memorize these 4 graphs. And these are the graphs of y is equal to a times b to the x. Right? And whenever you have a graph y equals ab to the x, it's either an exponential growth or an exponential decay problem. Right? Exponential growth, exponential decay. Or it's exponential decay where a is negative, so it flips. Or it's exponential decay where a is negative and it flips. And then what we do is, given a problem, let's look at the same 2 problems we looked at before. We looked at y is equal to 2 times 3x plus 4 plus 5, or y is equal to 2, 0.75 x minus 4 plus 1. Well, both of these functions you can think of as being derived or another function with something added, and that is what we often call the parent function. You don't have to use that terminology. It's not that we're not insistent on it, but the idea of a parent function is you have exactly the same function shorn of h and k. So take away h and k, and you get y is equal to, this problem, y is equal to 2 times 3 to the x, and in this case you would get y is equal to 2, 0.75 to the x, and this is the parent function here. I put it in parentheses because this is just an easy way to name this these two functions. They don't necessarily have to. You don't have to use that terminology. But the key here is that this graph right here is simply this one, but moved left and right. H and K you can think of. I'm sorry, moved left and right, or H and K. So H and K, right? So what you do here is this function here is simply this function moved left and right and up or down. This one is the same way. You simply take this function and you move it H and K, or up and down, left and right, and then you get, that's how you get this function. So that we can call that the parent function. So that's the introduction to graphing with H and K. In part 6 we'll actually start working through the steps.